Hello everyone and welcome back to exercise number 39 of the SolidWorks Basic Tutorial Series. In this video, we're going to be designing a flanged bearing house. Now, as always, in designing this part, we're going to be implementing many of the SolidWorks features, namely the extrude boss base feature and extrude cut feature. We're also going to be using the fillet tool and the hole wizard tool to create these three drill holes at the top and 4 mounting holes at this side piece right here. Here we see the schematic drawing for exercise number 39. All dimensions, of course, are in millimeters. We have 2 pictorial views for the component, showcasing the isometric view here at the bottom and the trimetric view, basically what the component will look like at a different angle. And we have the top view, the front view, and the section view. And the section view was taken along this vertical line here, right? And we have notes. An important note here says, unless stated otherwise, all fillets have a radius of 2 millimeters. Now, we notice here, as we move along in the video, that there are certain fillet edges that don't have any dimensions on them. So by default, again, we need to assume that they have fillet radius of 2 millimeters. And the second note here is that all chamfers have a dimension of 1 millimeter by 45 degrees. So namely, if we look closely at the section view, we have 3 chamfers. Specifically, we have the chamfer for this top edge, bottom edge, and this side edge, corresponding to right here. See this top rim here and this side rim, and we have a rim at the bottom right here. All right. Okay. So, of course, we have an instruction here. We have a number of instructions, and we have a question. The question reads, what is the mass of this part in grams? All right. So after modeling this part within SolidWorks and assigning material, we are to determine the mass of this part. So reading the instructions here, one, it says open your 3D CAD system. Again, I'm using SolidWorks, but you could use Fusion 360, Onshape, FreeCAD, whatever it is. Model the part using the dimensions shown. Of course, you need to model the part according to the dimensions. And step 3 involves assigning material. And we're going to be using the ASI 10-point steel material, okay? Again, by default, we've defined the density for the material. Again, this is a material that comes along with SolidWorks. Finally, we're going to calculate the mass of the part rounded to the nearest gram. Okay, so looking at the part, let's look at this trimetric view here. We see that there are a number of features for the component. We have a circular base flange. We have 4 mounting holes, as we see here. Again, the top view showcases that very clearly. 4 equally spaced mounting holes. We have a central boss, a cylinder that basically corresponds or coincides with the center of this base flange. And there is an opening. There's a hole that goes all the way through the central hub or the central boss. The hole first begins with a diameter of 30 millimeters and then sort of narrows down to a diameter of 24 and then opens it up and again to a diameter of 28. Okay, so this is a stepped hole. And we have also a protruding feature here to the side of the component. So yeah, one of the tricks, actually, it's not actually a trick, but one of the steps that we need to do is to create an independent drawing plane that is independent of the front, top, and right plane that come along with SolidWorks. And this drawing plane needs to be basically 36 millimeters away from the center of the component, right? So it'll be a good idea if we model this component using symmetry, right? Yeah, that's pretty much it. So with regards to the SolidWorks features that we're going to use, we're going to be using the extrude cut tool. We're going to be using the extrude boss base tool. Many of the sketch tools we're going to be using, of course, in creating these 2D sketches. We're going to be using the hole wizard to create specifically these 3 mounting holes here at the top. As we see here, we have a specification of M4, metric 4, and they are 12 millimeters deep. In addition, we have a number of mounting holes here at the sides. The diameter is the same. It's M4, major diameter of 4. But a breakaway view here showcases that the depth of the cut or the depth of the drill should be 11 millimeters. Okay, so yeah, that's basically it. There's nothing much for me to say, but of course, step 1 would be for us to create the base flange for the component. And for that, we're going to select the top plane and draw a circle, and then use the extrude tool to create the thickness of the part. All right. Okay, so yeah, that pretty much outlines the description of the the schematic drawing for exercise number 39, but I just want to take this opportunity to thank you all. It's now the 31st of December, meaning that tomorrow is the beginning of a new year. I just want to thank you all for subscribing to this channel. So far, we've reached more than 150 subscribers. Happy New Year to everyone, and to all my viewers, to all of my subscribers. I remember uploading my first video. I think it was February. February. And I was pretty nervous, to be honest with you. I wasn't expecting, I didn't know what was the reaction going to be. Like, are people going to like my videos? Are they going to actually watch it? But thankfully, over the months, I've noticed that there was an increasing number of viewers. There were people subscribing to my channel. And there were people actually reaching out to me over email, asking for specific tutorials, and I was flattered, to be honest with you. I didn't expect this level of engagement very early on in my YouTube career, this YouTube journey. So yeah, as a commitment, I just want to thank you and say here that starting from next year, hopefully, I'm going to be uploading more videos, trying to improve the content. And yeah, so far, this was a blast for me. And 3D modeling has always been a hobby for me. I do this for fun. This is not a job for me. This is what I do, when I have free time to kill. So I thought to myself, might as well upload a video and let people benefit from what I'm doing. So once again, thank you and Happy New Year. So yeah, with that aside, let's jump right into exercise number 39. Okay, so we start by creating a new SolidWorks part. We set the background to plain white, and we copy exercise number 39 into SolidWorks. Okay, let me just make it smaller here. All right, so as I said previously, the first step would be to create the base flange for a component. So to do that, select top plane, sketch, and then go ahead and select circle, and from the origin, draw a single circle. All right. Looking at the figure here, we see that the base circle, the base flange, should have a diameter of 106 millimeters. So on your mouse, click your right mouse button and then move your cursor upwards to activate the Smart Dimension tool and assign a diameter of 106 millimeters. Now we need to extrude this 2D sketch to a thickness of 6 millimeters. So you can see here in the section view that the base flange has a thickness of 6 millimeters. All right. So go ahead and press S on your keyboard and then select Extrude Boss Base. Assign an extrusion thickness of 6 millimeters and then select OK. All right, so that creates the main body of the base flange. Now we're going to work on creating this central boss here, the central hub. So simply just select this top face, sketch, activate the circle tool, again by clicking your right mouse button and then moving your cursor to the right. And then from the origin, draw a single circle. All right. Looking at the figure, we see that this central boss has an overall diameter of 15 millimeters. We can see this in the section view of the component. So activate the Smart Dimension tool and assign a diameter of 15 millimeters. Now, of course, we need to extrude this 2D sketch to a given height. And from the figure here, we see that this central boss or this hub here should have an overall height of 63 minus 6, right? Because the extrusion, the 2D sketch, starts from the base flange, right? So press S on your keyboard, select Extrude Boss Base, and then go ahead and assign an extrusion height of 63 as the overall height of the component, minus 6, which is the thickness of the base flange, right? Which gives you a final answer of 57. That's the beauty of SolidWorks. I on purpose, entered this very simple arithmetic operation to show you that you can perform basic mathematics within SolidWorks. Anyway, so go ahead and select OK. All right. Now, looking at the component here, we see that we have this hole here. Sort of looks like a counterbore feature, but actually it's a stepped hole that starts large at the top and then narrows down the middle and then opens up again at the bottom. Right? So to do that, select this top face, sketch, activate the circle tool, And from the origin, go ahead and draw a single circle. This first circle here, this first hole has a diameter of 30 millimeters and a cut depth of 10. So 30, 10. All right. So activate the Smart Dimension tool. Assign a diameter for the circle as 30 millimeters. Press S on your keyboard. Select Extrude Cut. And we're going to cut this to a depth of 10 millimeters. Then press Enter. All right. So that creates the first stage of the central opening here. Now we're going to work on creating this part of the opening. So go ahead and select this face, sketch, and looking at the figure, we see that the circle that we're going to draw on this face right here should have a diameter of 24 millimeters, all right? So activate the circle tool. From the origin, draw a circle, then activate the Smart Dimension tool. And this circle should have a diameter of 24 millimeters, right? Now press S on your keyboard, Extrude Cut. We see here from the figure that the cut depth starting from this edge here should be 63, which is the overall height of the component, minus 18. Why 18? Because first of all, we have this cut depth of 10, and then we have this bottom cut depth of 8, right? 10 and 8 is 18. So 63 minus 18. All right, which gives us 45. Let's select OK. Now go ahead and select this bottom face, sketch, activate the circle tool, and from the center here, draw a circle. This bottom hole here should have a diameter of 28 millimeters. So activate the Smart Dimension tool and assign a diameter of 28 millimeters. Press S on your keyboard, Extrude Cut. And we're going to cut this to a depth of 8 millimeters. Again, this is according to the figure we've seen earlier. Okay, select OK. So that creates the opening that runs along the center of the component. If we have a section view here, we can see that it pretty much corresponds or matches with what we see in the section view. All right. Okay. Now we're going to work on creating these 4 mounting holes on the base flange. So to do that, very simply, just select this top face, sketch, and what we need to do first is draw 2 center lines, okay? The first center line, starting from the origin, needs to be horizontal. This horizontal center line corresponds to the x-axis, right here, starting from the origin, all right? And we need to draw another center line. So go up here, select center line. This time, the center line should be at an angle, all right? And if we look at the figure here closely, we see that these 4 mounting holes are situated on a pitched circle with a diameter of 90 millimeters. So go ahead and draw a circle, activate the circle tool, and from the origin, draw a circle. Select the circle, and then convert it into construction geometry. All right. Now we need to define the diameter of this pitched circle diameter right here. So select the Smart Dimension tool, and the pitched circle diameter should be 90 millimeters. Select Trim Entities, and then go ahead and delete this extra line. And this point of intersection here corresponds to the position for one of the mounting holes. So the strategy here is actually just to sketch out the 2D profile right here, then use the Extrude Cut tools to create the full 3D feature for one of the mounting holes. So as you can see here in the pictorial views. And then we're going to use the Circus pattern tool to create the other 3 copies. All right, so we just create one, and then we'll work on the other. So let's go ahead and just convert this back to a solid line. We'll see why. Select circle, and starting from this point, go ahead and draw a circle. Activate the Smart Dimension tool, and looking at the figure here, we see that this circle right here, this semicircle, should have a diameter of 12 millimeters. So go ahead and assign a diameter of 12 millimeters for this circle. Now, select Offset Entities, select this line right here, and we need to offset this line in both directions at an overall distance of 12 millimeters, right? So go ahead and select bidirectional, and in each direction, we're going to offset the line to a distance of 6 millimeters. Overall, will give us a distance of 12, all right? And then select OK. Select this top face, convert entities to create the outer sketch of the this drawing surface, and then go ahead and select Extend Entities. And we're going to extend these two lines all the way to the perimeter of this circle right here. Okay. Now select Trim Entities and go ahead and delete any extra lines, leaving behind the sketch that we need for the circle. You zoom in very closely here. We see that there are extra lines here, so delete that. And delete this line as well. Okay. Okay, so now we only have the 2D sketch for this mounting feature. So now just press S on your keyboard, Extrude Cut. Select the sketch, and we need to cut this 2D profile right here. As you can see here, there's a comment, cut depth of 2 millimeters, right? So go ahead and assign a cut depth of 2 millimeters. And then select OK. All right. We're not done yet. We need to create this mounting hole here that goes all the way through the base flange. So select this top face, sketch, activate the circle tool, and starting from this center right here, the center of this circle, draw this one smaller circle. And from the figure, we see that we have 4 mounting holes, and each hole has a diameter of 6 millimeters. All right. So activate the Smart Dimension tool and assign a diameter of 6 millimeters. Now, very simply, press S on your keyboard, Extrude Cut, and we're going to cut this 2D sketch, the circular profile, all the way through the base flange right here by dragging this arrow, and then select OK. All right, are we done yet? No, we need to create the other 3 copies of these mounting holes. So what do? We go to Features, and then go ahead and select Circular Pattern. Here's going to ask us for the direction, what circular direction you want to follow. It's just very simply select this outer edge. And here's going to ask us for the features. So now we'll just select this inner rim right here. Sorry, just undo that. Outer edge. Okay, so now we can see here a preview for the 4 mounting holes. And we need to make sure that they are equally spaced, right? So they are equally spaced. Now select OK. Okay, so now that creates the 4 mounting holes for the base flange. Are we done yet with regards to the base flange? No, we still have to fill out certain edges. Specifically, we have this edge right here, and we have an edge here that between the central hub and the top face of the base flange. So there's a comment here. There's a very important comment here. What does it say? Unless stated otherwise, all fillets had a radius of 2 millimeters. So here we haven't defined the fillet radius for this, the top edge of the base flange. So automatically it's going to be 2 millimeters. So go ahead and select fillet, assign a fillet radius of 2 millimeters, and then select these edges, 1, 2, 3, and 4. All right, and then select OK. Now we need to round out this sharp edge between the central boss and the top face of the base flange. So select fillets. From the figure, we see that the fillet radius should be 14 millimeters. All right, so assign a fillet radius of 14 millimeters, and then go ahead and select this outer edge right here, and then select OK. All right. We're almost done now. We just need to create 3 drill holes here at the top face of the central boss. So what do? We need to select the hole wizard. All right, and we can see here that there are 3 holes, 3 drill holes actually, and they are M4 type M4, and 12 millimeters deep. All right. So what do? We need to select the hole type, which is a drill hole. The size should be 4 millimeters, and the depth of the cut, the depth of the drill should be 12 millimeters. Right. But before that, first we need to draw a pitch circle, right, to basically help us to situate the 3 holes for the mounting holes, these drill holes. So go ahead and select this top face, sketch. Let's put this to the side here. Select circle, and from the origin, let's draw a circle. Select the circle, convert it into a construction geometry, and from the figure, we see that this pitch circle should have a diameter of 40 millimeters. So activate the Smart Dimension tool and assign a diameter of 40 millimeters. Okay, so now we're ready to situate the one of the drill holes. So just exit sketch, go to features, hole wizard, select hole type. Here we're going to select drill, and again, I think we've fully defined the drill type here. Select position, select this top face. Now, very simply, we're going to situate one of these holes right here, one of the quadrants of the circles, and then select OK. Okay, so that creates one of the circles. We need to create the other 2 copies, so we're going to use this circular pattern here. So select circular pattern. Okay, and for the direction, we're going to select this outer edge, set the overall copies as 3, and equally spaced, and then select OK. Hide this construction geometry here. All right. So now we have one more main feature to model here, and that is this face right here, this 3D body, this protrusion here. So the strategy is that we need to create a new drawing plane that is independent of the front, top, and right plane that come along with SolidWorks. And this plane should be created in reference to what plane? In reference to the front plane. And it should be situated at a distance of 36 millimeters away from it, since the front plane here, in our case, is situated directly along the middle of the component. We need to create a new drawing plane that is 36 millimeters away from the front plane. All right. So select reference geometry, select plane. Here's going to ask us for the first reference. Go and select the front plane as our first reference. Okay. So basically what it's saying is that, okay, you want to create a new drawing plane, but how far away do you want it in reference to the front plane? And we've already talked about this. We said that we need a drawing plane that is 36 millimeters away from the front plane. So go ahead and assign a distance of 36 millimeters. All right, then select OK. Now we have a new drawing plane. So what are we going to do here? We're going to sketch out the 2D profile of this feature right here, which corresponds, if we look at one of the projections here, to this profile right here. All right, so we're going to use, obviously, the circle tool, the cut tool. So yeah, it's pretty extensive. So go ahead and right click on this and then select sketch, select circle, and starting from the origin here, move directly upwards so that the center of the circle will be directly overhead of the origin, and just drag the circle all the way to the outer edge of this cylinder. All right, since you can see here that the diameter of this circle is not defined, it's automatically just tangent with the perimeter of this base central hub, okay, central boss. Okay, so activate the Smart Dimension tool, and we can see here that the distance between the center of the circle and the bottom edge is 36 millimeters. So go ahead and assign a distance of 36 millimeters between the center of this circle and this bottom edge. This should be 36 millimeters. All right, now select center line and go ahead and draw the horizontal center line. Let's put this to the side here. Let's create another center line. Or actually, before that, let's draw a circle again. Let's convert this to a construction geometry. Let's assign a diameter for this circle, which is a pitch circle right here. We see that the pitch circle has a diameter of 54 millimeters. So the diameter of this circle should be 54. All right, and we're going to draw another center line all the way to the edge right here. We're going to set the distance, or the angle, sorry, between this line and this line right here as 45 degrees. Okay, now we need to select circle again, and starting from this point, or this intersection right here, as you can see here, right here, see, we're going to draw a circle, one larger circle. The diameter of this larger circle right here, we have 4 of them, should be 8 millimeters. So activate the Smart Dimension tool and assign a diameter of 8 millimeters. All right. Now what we need to do is very simply trim any extra lines leaving behind the base sketch. Okay. Now select circular pattern. For the entities to pattern, go ahead and select this line right here. Select change the points. We're going to drag this to the center right here. All right. So that creates the other 3 copies, and then select OK. Now we just do that again. Circular pattern. Entities to pattern. This circle right here. Okay. Now select trim entities again. Delete any extra lines. All right. Now press S on your keyboard. Extrude boss base. Reverse the direction and set the end condition as up to surface. Obviously, because we need to extrude this 2D sketch up to the cylinder, the central boss here, right? So go ahead and select this surface right here. And then select OK. Hide this drawing plane. Now we're almost done. We see here that we have certain edges here that are rounded out. Again, as I said earlier, any fillets, unless stated otherwise, automatically has a fillet radius of 2 millimeters. So what we're going to do, we're going to use the fillet tool, assign a fillet radius of 2 millimeters, and fill out any edges that we think that need to be filled out. So this is obviously going to take some time. Yeah, bear with me here. Okay, so I think that's all of the edges. So go ahead and select OK. Okay, let's give this one last look. Yeah, I think we got all of them. Okay, so now we need to create an opening here on this face. So select this face, sketch, select or activate the circle tool. And starting from the center of this point right here, this circle, draw a smaller circle. Right? And looking at the figure here, the section view, we see that there's an opening. Okay, there's an opening here, and the section view gives you the dimension. The circle should have a diameter of 42 millimeters. So go ahead and activate the Smart Dimension tool, and this should have a diameter of 42 millimeters. Now press S on your keyboard, extrude cut, and we're going to cut this to a depth. If we look at the section view, we see that the overall depth, that cut depth, should be 16. Okay. So assign a cut depth of 16 millimeters, and then select OK. All right. Now we're going to select this face, sketch. We're going to create a central boss on this face right here. So select circle, and starting from the center, draw a circle. Looking at the figure, we see that we have a central boss on this interface with a overall diameter of 28 millimeters. So go ahead and activate the Smart Dimension tool and assign a diameter of 28 millimeters for the circle. Press S on your keyboard, extrude boss base, And from the figure, we see that this central boss should have a diameter of 6 millimeters. All right. So go ahead and set the end condition as blind, and then set the extrusion height or thickness to 6 millimeters, and then select OK. All right, so now select this face again, sketch. We have an opening that runs all the way through the component, at least up to the central opening, and we need to draw a circle here on this face right here with a diameter of 20 millimeters. All right, so activate the circle tool. Starting from this point, we're going to draw a circle, and then activate the Smart Dimension tool, and the diameter of this circle should be 20 millimeters. Press S on your keyboard, extrude cut, and very simply, we're going to drag this arrow all the way through to the inner opening here, all right? And then select OK. Now I need to draw your attention that we have an opening at the bottom right here. Again, that opening starts from the inner face of this body all the way to the central opening for the component, the 2D profile of which is a rectangle, right? And the rectangle should be 8 millimeters long and 4 millimeters wide. And each of the 4 corners has a fillet radius of 1 millimeter. All right, so let's go ahead and select this interface, sketch, select the center rectangle tool, and then just go ahead and draw a rectangle. Activate the Smart Dimension tool. Again, according to the figure, this should be 8 millimeters. The length of this edge should be 4 millimeters. And we can see here very clearly that the distance between the bottom edge of the rectangle and the center of this circle overall should be 20 millimeters. So the distance between this edge and this circle should be 20 millimeters. Okay? And then don't forget we have to fill out these 4 corners here. So select fillet, assign a fillet radius of 1 millimeter, and then go ahead and select edge. You just select all 4 edges. And then select OK. All right, so that creates the 2D sketch for the rectangular opening. Now press S on the keyboard, extrude cut. And like we did previously, we're going to drag this 2D sketch all the way to the other side here. We can see that, okay, perfect. And then select OK. Are we done yet? No. There's something very important that we need to do. And that is, we need to define chamfers. We have chamfers for this top edge and this bottom edge, as well as this edge here for the opening, the mouth opening of the base flange here, the Flanged Bearing House. So we're going to select chamfer. And you can see here, comments here, all chamfers have a dimension of 1 degrees and 1 millimeter and 45 degrees. So we're using the distance and angle type here. So here automatically set to 1 millimeter and 45 degrees. So go ahead and select this top edge, this bottom edge, and this edge as well. Then select OK. There's one more thing left to do, and that is we need to create 4 drill holes right here. Okay, so what are we going to do? We're going to go to Hole Wizard, and from the figure we see that we have 4 drill holes, 1, 2, 3, and 4. And if we look at the section view, the breakaway section view here, we see that the drill hole should have an overall depth of 11 millimeters. So the drill depth is 11 millimeters. And as for the diameter of the hole, it's basically the same as these top drill holes here. So we're going to use an M4 type drill hole, okay, with a major diameter of 4 millimeters. So let's just go ahead and select this as 11 millimeters. Position, let's select this face. All right, so we need to position this in the right position, and then that's right here. And then select OK. All right, now we need to create the other 3 copies. So very simply, we're going to use the circular pattern tool. Here's going to ask us for the direction for the circular pattern. Select this outer edge. All right. And set the number of copies as 4. All right. So now automatically it will align itself with the center of these mounting lugs here. Then select OK. All right. So yeah, I think there's nothing left. We just check one last time. We've created these holes, the base flange. Yeah, I think that's everything. Now we need to assign the material for this component. So very simply, just right click here, edit material. And according to the image, we need to assign an ASI 1020 steel. So go ahead and select ASI 1020 and apply and then close. All right. And then we need to answer this question. What is the mass of this part? All right. So very simply, let's delete this image here. Go to Evaluate, Mass Properties, and we have a final answer here of 1,153.14 grams, or if you want to round things up, 1,153 grams, all right? And that is our final answer. Okay, so that concludes exercise number 39. I hope you all enjoyed this video. If you have any comments or questions, please leave them down in the comment section below. Please don't forget to like and subscribe as well. And once again, Happy New Year. Thank you all for following this channel and subscribing. So far, we've reached more than 150 subscribers. It's been a pleasure actually uploading these videos for you. And I look forward to uploading more videos next year. So until I see you again, have a nice one. Bye-bye.